Would you like to explain the differences between optimal values and the reference values and why one should focus on the former one?
Yeah, so the reference range is a population-based average, and it isn't intended, so if the population has certain values, you're within the 5% to the 95th percent range, and then if you're beyond to the left side of that distribution or to the far right of that distribution, it's considered abnormal or out of range. But generally, those reference ranges aren't intended for disease risk or even longevity. So, and the reference range doesn't tell you, how does it change with aging? Like if you see your values going up or down, it doesn't tell you, is that the right direction or the wrong direction? And the common thought, for people who get their blood tests, however often, once a year, twice a year, is, oh, my blood tests are right in the middle of the range, so I'm good. That's how I used to think about it. And I've heard others say it like that. But the fact is, for most biomarkers, that isn't true. So from my perspective, knowing how each of the biomarkers that are on just the typical blood test that you get from your doctor every year, the standard chemistry panel and the complete blood count, which are reflective of many organ systems, the health and functioning of many organ systems, and that these biomarkers have been studied for 50 to 100 years plus, depending on the biomarker. Some of these biomarkers have been studied for 50 years, some more than 100 years, like glucose. So there's a wealth of data. There's a wealth of data in terms of how they relate to disease risk and how they change during aging. Whereas in contrast, not that I'm, not to knock it, but think more recent things like the epigenetic clocks, which are also a measure of biological age, are more new. And there's much less data on what aspects of aging they're actually measuring, and then even randomized controlled trials to even optimize these things. So they're going to be even bigger than they are now. But so that's why I focus on the things that are tried and true. It's not the most cutting edge, knowing that something's been around for 100 years, but there's a wealth of data. So knowing that and doing as comprehensive literature reviews as I can, which means that, if I look up a given biomarker like albumin, I'm not just getting to the first paper I find and then, saying, well, that fits my bias, so I'm going to stick with that data. Like I look up literally all of the data, albumin and aging, and I see what the consensus data is even in the largest studies, because another variable is if I have a study that only looked at 200 subjects and I have a study that looked at 1 million subjects, which is the truth, right? So there's a little bit more to that, knowing that smaller studies can lead to either accurate results or inaccurate results, depending on the population. Whereas if you have larger groups, very large groups, now you should have a more reflective part of the story. So just going back to albumin, as an example, so I did comprehensive reviews how these biomarkers change during aging, and then also comprehensive reviews on how they relate to disease risk, and not just focusing on things like one disease at a time, which I've seen a lot of people do. Oh, this is associated with heart disease. Well, you may take a statin for your heart disease, but what's the risk for death from all causes? Is that because if that goes up and your heart disease risk goes down, is it a net positive or negative? So I focus on all-cause mortality because that's risk of death for all causes, right? So then putting those two pieces together, it should tell you now within the reference range, do you want your values to be high? Do you want them to be lower? Knowing how it changes with aging and disease risk. So with that in mind, then the fun part becomes, okay, I have this value for this biomarker and it's higher than it should be based on the Lustgarten quote unquote optimal range. How do I change that? For the common ones like, glucose or inflammation, those may be more relatively easy to change. But if I say mean corpuscular volume, the MCV, first of all, most people
that's very hard.
It may not be though. That's the thing.
Yeah.
But when, for starters, most people would hear that and they'd be like, "What even is that? I didn't even know it was on my test." So with the videos, I try to give a brief introduction into what it is, and then the aging and the disease risk. So the fun part then is figuring out which aspects of your lifestyle, whether it's diet, exercise, supplements, sun, whatever it may be, vitamin D, that impacts the biomarkers, and that takes time. So there are companies that promise, whether it's based on a blood test or a gut microbiome sample or whatever it may be, that'll say, we're going to sample your data and give you precise dietary recommendations off one blood test or one stool sample. which from my
Yes.
experience is ridiculous. I mean, this takes time. You need to have a lot of your own. Like, imagine if you had a scientific study and you said, we did one data point and we accurately, in one data point in one person, the study's underpowered and undersized. It wouldn't fly. So you need a lot of data, a lot of measurements, and rigorous trial and error to accurately get close to what the truth may be. So yeah, that's my approach in a nutshell.